Hi friends, welcome to a new episode of I Square. So, welcome to the class 12th section and we are starting with vector algebra. So, you may have heard vectors, scalars and so on. What might be a vector? There are several definitions for vectors as well as scalars, but the basic definition or the content in all the definitions are the same. Suppose that I have marked just a point here. Let it be a point. We know that it does not have any direction or it is directionless. It's just a point in the plane, whereas it is not directed towards any direction. But it has certain magnitude, the magnitude of this point. So, anything in nature or anything which has magnitude only and has no direction can be named as a scalar. So, scalar is nothing but something which has only magnitude. So, something which has only magnitude can be named as scalar, no direction. So, a scalar is directionless. So, anything which has only magnitude but directionless can be named as a scalar. Now, suppose that I am traveling from Ernakulam to Kottayam. That means that I have a direction. I am in a direction which is from Ernakulam to Kottayam. So, I have a direction as well as I have a magnitude also. So, my weight is my magnitude, also I have a direction now. So, such quantities, that is vectors, are those quantities which has magnitude as well as direction. So, magnitude and direction. So, those quantities which have magnitude as well as direction can be named as vectors. So, if suppose that you are in a bus and you are moving from Trivandrum to Kasaragod, then also you have a direction that, and the bus also has a direction. Bus is moving from Trivandrum to Kasaragod, so it has a direction as well as it has a magnitude. So, we can name such quantities which has both direction as well as magnitude as vectors. Now, suppose that as I have said, when I am moving from Ernakulam to Kottayam, that is, suppose that I am moving from Ernakulam to Kottayam. See, I have reached Kottayam. This is my starting point is Ernakulam, and now my destination is Kottayam. So, I have started from Ernakulam to Kottayam. In vector algebra, this movement can be represented by a vector like this. So, the movement or the motion can be, or the direction can be indicated using the arrowhead as well as, also we said that every vector must have a magnitude. So, the magnitude is denoted by the distance. So, in general, we can denote any vector like this. So, it has a magnitude as well as a direction. So, something with magnitude and direction can be named as a vector, and we can name this as the terminal point. So, the point with which the motion ends can be named as the terminal point, and the point where which the motion begins or the movement begins or the direction begins can be named as the initial point. So, for this vector or for any vector, there is two quantities, namely initial point as well as terminal point. Also, we said that any vector should have a magnitude, and the magnitude is the distance from initial point to the terminal point. That is, the magnitude is the distance. Distance the distance from initial point to the terminal point. So, any vector in vector algebra can be represented of the form like this, with an initial point and a terminal point, and the distance in between them is called the magnitude of the vector. So, we can have any vector with a magnitude and a direction what all things we do check whether to check whether it is a vector or not? Always focus whether it has a direction and whether it has a magnitude. If it has a direction as well as a magnitude, we can simply say that that is a vector. Now we shall define the position vector. The position vector, as the name suggests, position. So position vector is a vector which deals with the or which indicates the position of a point. So position vector is nothing but a vector which indicates the position of a point. Suppose that we are provided with the Cartesian coordinate system or the xy plane. Let it be the x-axis and let it be the y-axis. We are provided with the Cartesian coordinate system. Now suppose that we have a point here. We know that in the xy plane we have this point can be named as xy. Then the position vector or the position of the vector indicating the position of this point, let it be p of xy. The vector indicating the position of this vector, position of this point is the vector which starts from the origin and ends in the point. That is, the position vector of the point p of xy is nothing but the line segment AB with the arrowhead towards there. So here we can draw the position vector and we can name this as r bar. Always remember that since any vector can be represented of the form like this, if we name a vector as AB, we must show an arrow in the top of that name to show that this is a vector and it is directed. So that we are showing that it has a magnitude as well as direction. By this symbol we means that this is a vector. So the position vector can be named as this. So this is the position vector of AB or the position vector of the point P, and we can name it as r bar, or also we can name it as AB bar. So clear. Now coming to the three coordinate system, that is we have an x-axis, y-axis and z-axis. Suppose that we are provided with the three-dimensional geometry, that is let it be the z-axis and this is the x-axis and let it be the y-axis. Suppose that we have a point here, then this point can be named as P and it has three coordinates, namely x, y, z, because it is in the three-dimensional plane. Now we can find the position vector of this point also just by drawing a vector which starts at the origin. For a three-dimensional plane, origin is nothing but 0, 0, 0, and the vector which starts at the origin and ends in the point is called the position vector of this point. So we have learned about the initial point, the terminal point, the magnitude as well as the position vector of any vectors. Similarly, we can find the position vector of any vector. Let there is a point Q, then we can find the position vector as A. There is a point R, then we can find the position vector as B. So just remember that A, B are the arbitrary names given to those position vectors. So in order to locate any point on the plane, whether it is in the Cartesian coordinate system or whether it is in the three-dimensional coordinate system, it doesn't matter. What we have to do, we have to locate the point by the help of a position vector. The position vector should start from the origin and ends in that point, and the arrowhead should be at the point, which indicates that this is a vector and has magnitude equal to this. So now we can move to the magnitude of the position vector. Suppose x, y, z be the point and 0, 0 be the origin. 0, 0, 0 be the origin. We know that the magnitude of any vector, see the distance from where to where, distance from origin to the point P. So the magnitude is nothing but the distance from the origin to the point P. Then we can find the magnitude of the position vector just by finding the distance from the origin to P, right? So let r bar be the position vector, then the magnitude of the position vector is denoted by absolute value of r bar. It is equal to, see, r is the position vector from the point 0 to the point P. Then by distance formula we have r bar is equal to nothing but x minus 0 the whole square plus y minus 0 the whole square plus z minus 0 the whole square equal to root of x square plus y square plus z square. So r bar is nothing but root of x square plus y square plus z square. That is for any point x, y, z, the magnitude is nothing but root over x square plus y square plus z square. Clear? So we shall move to the direction cosines. So in order to learn about direction cosines, we shall look into this picture. Let P be a point in the three-dimensional plane, and we have P is equal to P of x, y, z. Since it is in the three-dimensional plane, it does have three coordinates and we have x, y and z. Now, this is the z axis, y axis and x axis. Now we are going to draw the direction vector or the position vector of the point P. This is the position vector. It starts from the origin and ends in the point P. So OP is the position vector of the point P. Now we shall draw perpendiculars to axes. Let the perpendicular from P to the x-axis be AP. This is A. So P to the x-axis be AP. The perpendicular from P to the y-axis be PB. See PB. And the perpendicular from P to z-axis be PC. The dotted lines in the black. So we have drawn some perpendiculars. Now we are going to define the direction cosines as well as the direction ratios. See, the angle by which the position vector r makes with the x-axis can be named as the angle alpha. The angle by which r makes with the y-axis can be named as beta, and the angle by which the r vector or the position vector makes with the z-axis can be named as gamma. So we have alpha as the angle by which the position vector makes with the x-axis, beta is the angle by which the position vector makes with the y-axis, and gamma is the angle by which the position vector makes with the z-axis. Now the direction cosines are nothing but cos alpha, cos beta and cos gamma. So we have direction cosines cos alpha, cos beta, cos gamma, where alpha is the angle by which the position vector r makes with the x-axis, and similarly beta and gamma. So if we can find alpha, beta, gamma, then the direction cosines is nothing but cos alpha, cos beta and cos gamma direction cosines. Now look here that AP is the perpendicular from P to A. So this is 90 degree. Okay. So this is a right angled triangle with the hypotenuse equal to nothing but OP. See, it may look like this is the one side with longer distance, but actually this is the longest side of this triangle, and this is a right angle triangle. So this is the hypotenuse OP. So from this right angle, always focus on this right angle triangle, this right angle triangle. This is the hypotenuse and this is the side and this is the angle 90 degree. From this right angle triangle we have cos alpha is equal to, for any right angle triangle, do you remember this result? For any right angle triangle ABC, this is theta, cos theta is equal to adjacent side by hypotenuse, that is BC by AC. Always this is valid. For any right angle triangle, cos theta is equal to adjacent side by hypotenuse. Always remember this result. So by that we have cos alpha is equal to adjacent side. This is the angle alpha. Adjacent side is nothing but x. X by hypotenuse is nothing but the position vector, which is r. So we have x is equal to r cos alpha. Right, r cos alpha. Similarly, y is equal to r cos beta and z is equal to r cos gamma. See, For y, we can consider this right angle triangle with the hypotenuse equal to the position vector r and adjacent side is equal to OB. Similarly, we get y is equal to gamma cos r cos beta and z is equal to r cos gamma. Is it clear? So, we got x, y and z. This quantity is called the direction ratios. So, we have direction cosines and direction ratios. Direction cosines are nothing but cos alpha, cos beta, cos gamma. Direction ratios are nothing but the x, y, z coordinate, which are r cos alpha, r cos beta and r cos gamma, where alpha, beta, gamma are the angles made by the position with the vector with the respective axis. So, you may have understood the concept of direction cosines and direction ratios. Direction cosines are nothing but cos alpha, cos beta, cos gamma, whereas direction ratios are nothing but r into cos alpha, r into cos beta, r into cos gamma. Just remember that, it will help you in doing problems. We shall discuss the application of these things in the problem section. So, we shall move to the types of vectors. So, now we shall move to the various types of vectors. The first type of vector is zero vector. That is, as the name suggests, this vector is a vector having magnitude 0. Zero vector. How a vector can have magnitude 0? Always remember that the magnitude of a vector is nothing but the distance between initial and terminal points. So, when we say that a vector has 0 magnitude, it means that the initial point and the terminal point coincides, So, a vector is 0 vector if the initial point and the terminal point comes on the same point, coincides. So, then the distance between the initial point and the terminal point is nothing but 0. So, the distance is 0, hence we can call it as zero vector. The second vector is unit vector. As the name suggests, the second vector is unit vector. Unit means 1. So, a vector is said to be a unit vector if it has magnitude 1 unit. So, any vector with magnitude 1 unit can be named as a unit vector. Then the next vector is co-initial vectors. Co-initial vectors. These names are important since many questions give us only names, so we have to understand what the name suggests. So, co-initial vectors. See, as the name suggests, co-initial, which means that these types of vectors have the same initial points, just like this. See, this vector starts from this point, another vector started from this point again, another vector started from the same point again, and this continues, and what only remains constant, the thing only remains constant is nothing but the initial point. So, we can say that these vectors are co-initial vectors. So, in brief, a co-initial vectors, two vectors are said to be co-initial if they have the same initial point. Next category is the collinear vectors. Collinear vectors. Collinear. Linear means line. So, something which lies on same line or parallel to the same line. So, if we have a line like this, if we have vectors which are parallel to the same line, then we can say that these types of vectors are nothing but collinear vectors. So, collinear vectors are those vectors which are parallel to the same line. Next category is the equal vectors. Equal vectors. So, now two vectors can be equal vectors if they have the same magnitude as well as the same direction. So, if we have two vectors, don't bother about the initial point of those vectors, just check that if they have the same magnitude as well as the same direction. If suppose that I have a vector like this and suppose that I have a vector like this. So, here both of these vectors have different initial points, right? But the magnitude and direction remains the same. So, we can say that these kinds of vectors are nothing but equal vectors. Next category is the negative of a vector. Negative of a vector. A vector is said to be negative of another vector if, suppose that I am moving from, the first example itself, I am moving from Ernakulam to Kottayam. On reaching Kottayam, all on a sudden I changed about turn and go back to Ernakulam. That means I have changed my direction, but the magnitude, the distance between these 2 points remains the same. That is, if we have a vector from this A to B, if we are changing the direction of this vector, that is from B to A, but the magnitude remains the same, then we can say that A, vector B. Then we can say that vector B equal to negative of the vector A. So, a vector is said to be negative of another vector if they have the same magnitude but the direction is reversed. So, we have various categories of vectors like zero vector, unit vector, co-initial vector, collinear vector and equal vector, and at the last we learned about the negative of a vector. So, I hope you understood these types of vectors. Now, we shall move to the first problem. Represent graphically the displacement of 30 kilometer 40 kilometer 30 degree west of south. So, we have to represent a vector in the coordinate plane. So, the question is, we have to represent a vector, or the vector is displacement vector given in the question, and the question suggests 40 kilometer 30 degree west of south. This is the question. See, 40 kilometer 30 degree west of south. So, first of all, west of south, which means that we have to draw a plane which marked with the direction north, south and west, east. North, south, west, east, right. So, first of all, always look into the question well. So, we have 40 kilometer 30 degree west of south means that whenever there is a need for draw a vector which satisfies all of these conditions, first condition is we have to draw the plane like this. Now, 40 kilometer is nothing but distance, which means that distance, we know that the magnitude of any vector is nothing but the distance between the initial and the terminal point. So, 40 kilometer means the distance, hence we can say that this is the magnitude of the required vector. So, our vector has magnitude 40 kilometer. Now, 30 degree west of south, which means that we have to mark 30 degree from the south to west. So, we get a vector like this, 30 degree west of south. So, we have to mark 30 degree from south to west to get a vector like this. So, this is very important because this angle determines the position of the vector, or the position of initial point, or the inclination of the vector with respect to the coordinate plane. Okay. Now, we have 30 degree west of south. We have a vector like this, also provided the magnitude of the vector, what is 40 kilometer. So, this is our vector. This vector which has magnitude 40 kilometer and inclined 30 degree west of south is the required vector. The question was very easy if you observe the question well. Otherwise, if the question seems well, very easy, but there is a chance for mistakes, because if we mislead these questions or the hints to another, or if this direction goes wrong, the answer will be wrong. So, always stay focused in the question, which means we have to read the statement exactly as it said, otherwise we lose the question. So, we shall move to some more questions. The exercise, first exercise, we have to identify certain vectors, whether it is vectors or scalars. Classify the following measures as scalars and vectors. The first question is 5 seconds. 5 seconds. Since it is just time and it is directionless, we can directly say that this is nothing but scalar. Next one is 1000 meter cube. 1000 centimeter cube. Now, centimeter cube is unit of volume. So, 1000 centimeter cube is nothing but 1000 volume of something which has magnitude 1000, but volume doesn't have any direction. So, it is also scalar. The next one is third one, Newton, 10 Newton. See, Newton means something which indicates force, a unit which indicates force. We know that force is nothing but F is equal to mass into acceleration. Mass into acceleration gives a magnitude as well as acceleration is a vector. It has direction, acceleration in some direction. So 10 Newton is nothing but force. Force is a direction. So we have this is a vector. The next question is 30 km per hour. Again, the unit indicates speed. We know that speed is nothing but a scalar. So this is directly a scalar. And the last one, second last one, 10 gram per centimeter cube. See, gram per centimeter, always focus on the unit. Gram per centimeter cube is nothing but density. So gram per centimeter cube is density, and again it is a scalar. And the last one, sixth one, 20 meter per second towards north. So 20 meter per second towards north. Here towards north indicates the direction. Also 20 indicates the magnitude. Hence it is clearly a vector. So I hope you understood the topic very clearly. If you have any doubt in this section, please comment it on the comment section. We will give up you the necessary instruction to clear the doubt. Thanks for watching. Stay tuned.